Hey guys, alright, today we're doing a video for 3-2, central and inscribed angles. We're going into the realm of circles, and we're bringing some old friends along to help us get through it. Alrighty, so now I have a circle here. A circle is a total of 360 degrees. What does that mean? That means that somebody smarter than me took a circle and broke it up into 360 parts. Then gave that a unit and they called it degrees. This section of this circle or this arc is 95 degrees. This here in green is a central angle. When I take my protractor and I measure this angle, I get, and this is probably hard to see on the video, but I get 95 degrees. Now, if I can get this off, there we go. This orange angle is called an inscribed angle. It's defined as inscribed because it goes from one point of the circle to the other, and the angle is inside the circle. So that is the definition of inscribed. When I measure this, I have about 47 degrees. Right? 95 degrees cut in half. So we could develop two equations or two rules for this. For a central angle, I can say that the angle equals the arc. For the inscribed angle, I could say that 2 times the angle equals the arc. Okay, let's see how that helps us solve some problems. First example. You can see that? Good. All right, I have here a triangle inscribed inside a circle. But they gave me the outer arc here. So they gave me this, okay? And they gave me the angle. Well, this here creates an inscribed angle. If I took this side away, I have an inscribed angle. And so we just talked about this, right? I'm going to use 2 times the angle equals the arc. And if you remember the mid-segment, it is an evil eggplant question. So I'm going to multiply this by 2 and set it equal to 11x plus 14. I'm going to distribute. I'm going to solve 14. Oops, almost lost that. Subtract 4, subtract 4. I'm going to subtract 11x and subtract 11x. So I subtracted that out. I subtracted that out. Now x equals 10. And now the only issue is, if we could read the problem, it wants me to find n, the angle n. So I have to plug in. So now I'm going to plug in 10. 6 times 10 plus 2. That gives me 62 degrees. Remember that the unit we're working with here is degrees. Okay, next. This here, all these angles converge on the center. Right, this is a diameter here. And I have half a circle. Half a circle gives me 180 degrees. So what that means is I could add all of these up to 180 degrees. So I have 26x minus 3 plus 45 plus 60 equals 180 degrees. Okay, now I'm going to put this all together. So 26x, this is going to be, let's take a look. Plus 102, let me just double check that so I know what I'm doing. Negative 3 plus 45 plus 60, and that gives me 102 equals 180 degrees. Now I'm going to subtract 102 and I'm going to get 26x equals 98. I'm going to divide by 26, and x equals 3. All right, now here it just said solve for x. Just says solve for x. So that means I am done with this problem. Okay, last one. So now this guy, right, has a point. I kind of want to look at it this way. Has a point from one side of the circle to the other. So, and the angle's inside the circle. It is not touching the center, which is probably about there. So this is an inscribed angle, or it's an evil eggplant. So what I'm going to do is I'm going to do 2 times the angle equals the arc. I'm going to say 2 times 80 equals 23x minus 1. So I get 160 equals 23x minus 1, and I solve. So plus 1, that's 161 equals 23x. Let's take a look. So 161 divided by 23. And the answer is 7. X equals 7. Once again, it says solve for x, so I've solved the problem. Just my hints to you guys is keep in mind that circles have 360 degrees inside them, and kind of look at these as puzzles. Know your rules, and just try to dissect the question the best that you can. All right, guys. I hope you guys found this video helpful.